We have been, today and yesterday, we were graphing inequalities, so we're going to start actually writing inequalities from situations. Most of the problems that we're going to look at today are in standard form. You know, hopefully, how to write equations in slope-intercept form, because you've been writing equations in slope-intercept form for years. But now we're going to actually learn how to write them in standard form. They're a little different, but they're really not that hard. So when we look at this, let's think about our strategy that we use, our ruler strategy. We always start by reading the question, and as we read, we underline. Okay. So Rolanda is responsible for recycling metal cans and plastic bottles. Write a linear inequality. So that's important because that tells me I'm not using an equal sign. I'm using an inequality sign that could be used to determine the number of bags of cans, C, and the number of bags of bottles, B, Rolanda can send to the recycling center if the recycling truck holds no more than 40 bags. Okay, so this one is going to be a little bit different. Now that I've highlighted and underlined, I'm going to actually list what I know. So I know that I'm doing an inequality. Okay, I know that bags, so cans is C, and bottles is B, okay? And I can have no more than 40. Now, first thing I need to think about is what does no more than mean? Okay, so remember the strategy we learned for that is we draw a greater than, an equal, and a less than. So if I have no more than 40, does that mean I can have more than 40? Well, no. Can I have exactly 40? Well, if I can't have more than 40, I could have exactly 40. Could I have less than 40? Yeah. So my inequality sign is going to be less than or equal to. So I'm going to say cans and bottles has to be less than or equal to 40. Okay? I want you to try the next one. This one's a little tricky. Well, you know what? Let's do this one together too. Okay? Paige is buying asparagus and bananas at the grocery store. Why she's doing this, I don't know, but this is what Paige is doing. Okay, asparagus costs $3 a pound, and bananas. Here, let's get our highlight on. Asparagus costs $3 per pound. Bananas cost 50 cents per pound. I'm writing an inequality, and I want to represent the number of pounds of asparagus A and pounds of bananas B that Paige can buy with a $20 bill. Okay. Now, it says inequality, and even though it says with a $20 bill. Why is this an inequality? I want you to take a second and write down an answer. Write down why you think this is an inequality. Okay, the reason this is an inequality is because she has $20. Can she buy $21 worth of asparagus and bananas for her weird asparagus banana salad? No, she only has $20. That's the most that she can spend. So, if I'm writing this down, I have an inequality, and the most is $20, okay? A is asparagus, and B is bananas. So again, if I look at my strategy, greater than, equal, or less than, can I spend more than $20? No. I could spend exactly $20 or less than $20. So my sign is less than or equal to. Now, this is the thing. When I look at this, I have number of pounds, okay? Well, 50 cents is money, so somehow I have to turn this into money. If I have bananas at 50 cents a pound, if I have 50 cents for each pound of bananas and $3 for each pound of asparagus, that should be less than or equal to $20. Okay? Because in this case, in this one I had bags plus bags equals bags. This one I have money plus money equals money. So remember when my variable is not the same as my answer here, so like I'm ending up with money. I'm not ending up with pounds. If I was ending up with pounds, then I would do A plus B is less than or equal to 20. But since I was ending up with money, that means I got to do something to these pounds to turn them into money. 50 cents for every pound of bananas plus $3 for every pound of asparagus should be less than $20, less than or equal to $20. Okay? And I know this is tricky. You've never written these kind of equations before, but that's why we're practicing it. Okay? I want you to try to write the inequality for number 3. All right, so first thing I'm going to do with my ruler strategy, I'm going to read an outline. So I'm going to spend no more than $72 buying athletic shorts and t-shirts. Okay, so I'm buying shorts and shirts. The shorts will cost $12 each. And the t-shirts will cost $8 each. Okay, X is shorts and Y is shirts. So I'm going to right now, I'm going to label this. X is shorts, Y is t-shirts. Okay, so I'm going to label that right now because I don't want to get confused. Okay, oops, something fell. Okay, I know that my shirts are $8 each. And my shorts are $12 each. Okay, so if I'm writing an inequality to represent the situation, and I'm spending no more than $72. Okay, now a lot of you think that writing equates with a lot of work, but remember, writing equates with getting it right. I want to get it right. Okay, so I have greater than, equal, less than. Okay, if I can spend no more than $72, I can't spend more than. I could spend exactly or less than, so it's less than or equal to. And it's not always less than or equal to, but honestly, a lot of times in real world situations it is. But it's not always. Okay, so remember, no more than $72. So that means I have to end up with less than or equal to $72. So that means if this is the number of t-shirts and X is the number of shorts, then I have to convert that into money. So shorts are $12 for every pair of shorts and $8 for every shirt. Okay? Now, when I graph this inequality, what method should I use to graph the inequality? Like we practiced in class today, we're going to use the cover-up method. So remember, I'm going to look for my two intercepts. I need one that starts with 0 and one that ends with 0. So for my starting with my y-intercept, I'm going to cover up the x term. I get 8y is less than or equal to 72, so we're going to say 8y is equal to 72. I'm going to divide both sides by 8. I get y equals 9. So my y-intercept is 9. When I cover up my x, I get 12x is less than or equal to 72, so 12x equals 72. I get x equals 6. Okay? And then I'm going to plot those 2 points. I'm going to put a point at 0, 9. I'm going to put a point at 6, 0. Now remember, I'm going to sketch a light line, just a very faint line, because I want to see where my boundary is. But I don't know what my boundary is going to look like yet, so I'm not gonna like make it too dark. It might be a dashed line, it might be a solid line. Okay. Now, when I graph it, I'm going to make my crazy table. Here, I kind of ran myself out of room here. So I have x, y, 12x plus 8y, less than or equal to 72, and my check mark. Okay, so let's use, for a point above the line, let's use 0, 10, because this point right here is above the line. For a point on the line, let's use 0, 9, because it's right there, and for a point below the line, let's use 0, 5. I like using the intercepts, like the y-intercepts, because they're really easy to see, they're easy to write coordinates for, and they're easy to solve. So 12 times 0 plus 8 times 10 is 80. 80 is greater than 72. So that points out. 12 times 0 plus 8 times 9 is 72. That's equal to 72, so that one's okay. 12 times 0 plus 8 times 5 is 40. 40 is less than 72, so that's okay. So that means my shaded area is going to be below the line, and my line is going to be solid because the point on the line was, so we have above, on, and below. My above and on were checked. My below and on were checked. Okay? So that's what you should have had that's what we should have graphed. All right? Now, let's look at which solutions stay within our budget of $72. Well, we can do it two ways. We can either substitute them in like we did here and see if they're less than 72, or we can, now that we've got it graphed, we can look at the graph. So if I go, so shorts are X and shirts are Y. If I go over 2 up 5, that is in the shaded area. So this is Good. Over 0 up 9, that's on the line. That's good. Over 4 up 4, that is outside of my shaded area. That one is not part of my solution set. Over 6 up 2, that is outside of my shaded area. Not part of my solution set. Over 1 up 2, inside my shaded area. It's true. Over 3 up 8, outside of my shaded area. That's false. Over 3 up 3, inside my shaded area. That's true. Okay, so you see how once I have it graphed, I can use it to test points. But if I don't have it graphed and I don't want to graph it, I could also, like for this point here, I could say, okay, well 12 times 2 plus 8 times 5, that's 24 plus 40, that's 64, should be it's less than 72. Less than or equal to is okay, so this point would have been inside my shaded area. So I can test it either by substituting like we do here and see if it's a check, or I can substitute by graphing it once I have the graph. Okay, so the next question is kind of like a question like you would maybe see on a test. Would buying 4 athletic shorts and 3 t-shirts keep you within your budget? Why or why not? Okay, so if I buy 4 shirts and 3 shorts, well, that looks like it's on the line, but I'm not positive. So I'm going to check. I'm going to say 12 times, and again, I'm substituting back into my equation up here. I'm going to say 12 times 4, which is x, shorts, plus 8 times 3. 12 times 4 is 48. 8 times 3 is 24. 48 plus 24 is 72. Is 72 less than or equal to 72? Yes, it is. Yes, because I would have exactly enough money. Okay? If I decide to buy 2 shirts, what's the maximum number of shorts I can buy with $72? Well, if I look at my graph, if I go over 2, I think 6 is the most I can get, because if I buy 2 pairs, so let's say I buy 2 t-shirts, that's my y. So 12x plus 8 times 2 has to be less than or equal to 72. Okay, well, I think the most I can buy is 5. I'm going to check that. Let's say 12 times 5. That would be 60 plus 16. Oh, I guess that doesn't work. That's 76. So that's too much. That's weird. How did my line fail me? Oh, wait. What? You know what I did wrong? Y'all, what did I do wrong? I substituted it into the wrong place. 2 t-shirts are $8. Oh, what? Oh, look at what I did. Check me out. Look at what I did wrong. Look right here. Shorts are down here. So I want to buy 2 t-shirts. I should be going this way. And since I'm right on the line, I'm not positive if that's going to work. I think it's 4. So 12, 5 pairs of shorts plus 8 times 2 shirts is 60 plus 16, that's 76. That's greater than 72, so that won't work. So 4 is the most that I can buy. And I justified that with work. Okay? I know that was crazy. We're gonna save these examples in the back, and we're gonna do them in class tomorrow. Okay? So if you want to look them over, that's fine. But we're going to save number 4 and 5, and we're going to do them in class when you come in, kind of as a review to go over it. I want you to think about what we did up here, and I want you to write down questions. I want you to come up with some questions, some things that you don't understand, and I want you to ask them of me in class. You guys have to be brave. So I will see you in class tomorrow. Make sure you finish your homework, and have a good night.